What if you could see in the dark? Not with bulky night vision goggles, but with your own eyes. And what if the same technology that gave you this superpower could also cure blindness for millions? It sounds like science fiction, but thanks to the incredible world of nanotechnology, it's closer to reality than you might think. Today on G Fun Facts Online, we're diving into the amazing story of Tellurium nanowires, tiny engineered strands that are promising to revolutionize vision as we know it. First, a quick refresher on how we see. At the back of your eye is a delicate layer called the retina. It's packed with photoreceptor cells, rods and cones, that act like tiny light detectors. They catch light and convert it into electrical signals, which your brain then magically interprets as the world around you. But for millions of people with conditions like retinitis pigmentosa or macular degeneration, these crucial photoreceptor cells get damaged and die off. The connection between light and the brain is broken, leading to vision loss and, eventually, complete blindness. Enter our hero, Tellurium. It's a silvery white metalloid, and it has some truly special properties. Scientists have figured out how to sculpt tellurium into impossibly thin wires, thousands of times thinner than a single human hair. These aren't your average wires, they're nanowires. And because of tellurium's fantastic ability to conduct electricity when light hits it, these tiny structures are the perfect building blocks for an artificial retina. So how do you fix a broken retina with these nanowires? The concept is brilliantly elegant. Researchers weave these nanowires into a flexible, three-dimensional mesh. This mesh is then surgically implanted into the back of the eye, right where the damaged photoreceptors used to be. Once in place, this nanowire network acts as a team of artificial photoreceptors. When light enters the eye and hits the mesh, the tellurium wires absorb that light and instantly generate a tiny electrical current. This current then zaps the healthy retinal cells that are still hanging around, which pass the signal onto the brain. In essence, the nanowires bridge the gap, restoring the flow of visual information. And here's the most incredible part. Unlike other bionic eyes you might have heard of, this system needs no external power source. No batteries, no wires coming out of the head, no bulky camera packs. The nanowires are powered by the very light they detect, just like the real thing. This all sounds amazing in theory, but does it actually work? Well, the results from preclinical trials are stunning. Scientists implanted these nanowire prostheses into genetically blind mice. And it worked. The mice, which couldn't see before, suddenly regained their pupillary reflexes. Their pupils would shrink in response to light, a fundamental sign that the eye was communicating with the brain again. Even better, in behavioral tests, these mice were able to find and navigate towards LED lights, performing nearly as well as mice with perfect vision. The technology has also been tested in macaques, whose eyes are much more similar to ours. The good news there is that the implants prove to be safe and biocompatible, causing no harmful reactions. This is a huge step toward eventually trying this in people. But here's where it gets really wild. This artificial retina doesn't just restore normal sight, it might actually upgrade it. You see, human eyes can only detect a specific range of light we call the visible spectrum. But there's a whole world of light out there we can't see, including near-infrared or NIR light. The tellurium nanowires, however, can see it. In the experiments with macaques, the implants allowed their eyes to detect near-infrared light. What does that mean for a future human patient? It could mean dramatically improved vision in low-light conditions. Imagine being able to see more clearly in the dark, picking out shapes and details that would normally be invisible. It's not just restoring vision, it's potentially enhancing it beyond normal human capability. This technology represents a major leap over current approaches. Many existing retinal prostheses are clunky. They often require an external camera mounted on glasses to capture images, a processor to convert them, and a transmitter to send the signal to the implant. They need power. The tellurium nanowire approach, on the other hand, is self-contained. It's powered by light, it's minimally invasive to implant, and its ability to see a broader spectrum of light is something no other device can do. Of course, we're not quite at the finish line. There are still hurdles to overcome. Scientists need to ensure these implants are stable and effective for many, many years inside the human eye. They need to figure out how to manufacture these complex nanowire meshes on a large scale, affordably. And then there's the brain. The brain is incredibly adaptable, or plastic. But we still need to understand how it will learn to interpret this new kind of visual information, especially after years of blindness. And finally, rigorous human clinical trials are needed to prove safety and efficacy before this can become an approved treatment. Despite these challenges, the development of Tellurium nanowire retinal prostheses is a landmark achievement. It offers profound hope to millions affected by retinal diseases. It's a powerful example of how nanotechnology is solving some of humanity's biggest challenges. We are on the cusp of an era where we can not only repair the human body, but perhaps even augment it in ways we once only dreamed of. The future of vision is getting brighter, and it might just include the ability to see what was once invisible. Thanks for listening to G Fun Facts Online.